If you use an LLM every day, whether that's through a chat window or an API, you are almost certainly wasting tokens right now. Not because you're doing anything obviously wrong. That's the thing. Every habit I'm about to show you looks completely reasonable in the moment. Pasting in the whole document because why not? Leaving reasoning mode on because it's smarter. Sending the full chat history because context helps. Each one feels harmless. Together, they quietly inflate your bill, slow your app down, and in some cases, make your answers measurably worse. So in this video, we'll look at where the waste actually comes from, 12 places with the evidence for each. Let's start. Here's the framing for this whole video. Token waste is almost never one big mistake. There's rarely a single line of code you can point at and say, there, that's the problem. It's a dozen small habits. Each one looks reasonable in isolation, and they stack exactly like this into an infrastructure bill nobody planned for. That's why token waste is so hard to catch. There's no alarm, no error, nothing fails. The system works perfectly. It just costs 3 times what it should and answers slightly worse than it could. So we're going to go layer by layer through that stack. Each one is small. Fixing all of them is not. Waste number 1, and it's the big one. Context dumping. This is the habit of pasting in everything just in case. The whole PDF, the whole file, the whole thread, the window can hold it, so why not use it? Here's why not. Anthropic's own documentation says it directly. More context is not automatically better. As token count grows, accuracy and recall degrade. They have a name for this. They call it context rot. That's the vendor telling you in writing that filling their window has a cost. And you can see it in the benchmark numbers. On Anthropic's 8-needle retrieval test at 1 million tokens, roughly 1 in 4 multi-needle retrievals fails. So a 1 million token window is not 1 million usable tokens. It's capacity, not capability. The fix is simple to say and harder to do. Curate, don't dump. Send the exact slice that answers the question. Waste number 2. Even when your context is the right size, where you put things matters enormously. This comes from a paper called Lost in the Middle by Liu and colleagues, published in the Transactions of the ACL in 2024. Look at the curve. Information at the beginning of the context, high recall. Information at the end, high recall. Information in the middle, it falls off a cliff. And here's the part that should bother you. This is a positional attention bias. It happens regardless of how relevant the content actually is. The model isn't deciding the middle matters less. It's structurally worse at looking there. So look at the layouts below. On the left, instructions buried between blocks of context. That's the pattern most people write by default, and it's the weakest one. On the right, instructions at the top or instructions at the bottom. Both work. The rule: put your task and your critical evidence strictly at the top or the bottom. Never bury the instruction. The waste number 3. Running simple work on expensive models. If you're doing label classification, field extraction, JSON formatting, or basic rewriting on a flagship model, you're paying a premium for capability you're not using. That part is straightforward. But I want to flag a caveat here because the standard advice, just use a smaller model, is no longer automatically the cheapest lever. Here's a worked comparison. Take a coding agent with a 100,000 token system prompt, run it on a mid-tier model with prompt caching turned on, and it comes out roughly 6.7 times cheaper than downgrading to a small model with no caching. Think about what that means. You keep the stronger model, you keep the capability, and you still win on cost by a wide margin purely from how the prompt is structured. So yes, match the model to the task, but check your caching architecture before you assume a downgrade is your best financial move. Waste number 4, letting the model ramble. Look at the 2 tracks. Input or prefill runs at around $5 per million tokens on a flagship tier. Output or generation runs around 25. That's roughly a 5 times markup on the same token count. And it's not just price. Look at the shape of the bars. Prefill is one fast parallel pass. Generation is sequential, one token after another with no shortcut. So an uncapped output is expensive twice over. You pay the premium rate and you wait the longest. The fix costs you nothing. Cap your max output. Specify the format you actually want. Put it in the system prompt. 3 bullets, no preamble. You'd be surprised how much of your bill is model politeness. Restating your question, summarizing what it just said, offering to help further. None of that is the answer, and all of it is billed at output rates. Waste number 5. The vague prompt. Make this better. 4 words. Feels cheap. Feels efficient even. It isn't, because of what happens next. A vague prompt produces a vague answer. So you clarify. And when you clarify, you resend the entire context. Then maybe you regenerate and you pay for all of it again. That's the loop on the left. High cost, wasted context, going around and around. Now compare it to the right. Rewrite this email to sound polite, short, and professional. Under 120 words, longer prompt, more input tokens up front, and it lands in one shot. 2 mediocre round trips cost far more than one specific request every single time. So the counterintuitive rule is this: spending more tokens on the prompt usually spends fewer tokens overall. Specificity is a cost optimization. Waste number 6 and 7. These two go together because one is not using caching and the other is breaking it without realizing. First, the economics. On Anthropic, you set explicit cache control breakpoints. A cache write costs about 1.25 times the normal input rate. A cache read costs 1/10, that's a 90% discount, and you break even after roughly 2 reads. On OpenAI, caching is automatic above about 1,000 tokens of stable prefix at a 50% read discount. So if your app sends the same system prompt or the same schema on every call and you're not caching it, you're leaving most of your input bill on the table. Now the second sin, which is subtler and worse. Caching is strictly prefix-based. So look at the diagram. If you put a timestamp, a session ID, or a username near the top of the prompt, that variable data invalidates everything after it. The whole cached block shatters. And the outcome is genuinely worse than not caching at all. You pay the right premium over and over and never collect the read discount. One rule fixes it: stable content first, variable content last. Always. Waste number 8 and 9. 2 flavors of the same instinct. Send everything and let the model sort it out. On the left, code. You paste a 2,000 line file for a 5-line bug, and it's not just the token cost. Padding a query with irrelevant context actively degrades accuracy, and the damage concentrates in the material that looks similar to what you need. Semantic distractors. In controlled tests, injecting similar looking code dropped flagship performance by 31 points. 31 points. From context you added to be helpful, what the model usually needs is much smaller. The error message, the relevant function, and the stack trace. That's it. On the right, memory. A 40-turn chat history isn't context, it's sediment. Old assumptions, corrected mistakes, approaches you already abandoned, all still sitting there influencing the next answer, and all still being billed on every turn. The fix here is compaction. Summarize the thread, then restart from the summary. Keep the decisions, drop the dead ends. Waste number 10, retrieval. The default instinct in AirAg is to widen the net. Pull 40 chunks, stuff them all in, and trust the model to find the answer. But look at the curve. It's not a line going up, it's an inverted U. Retrieval accuracy improves as you add passages, peaks, and then falls off. This is from Long Context LLMs Meet RAG, published at ICLR 2025. And the mechanism is worth understanding because it's the opposite of what people assume. The damage isn't from random junk, it's from hard negatives, near misses, passages that are semantically relevant, that score well, that look exactly like the right answer, and simply don't contain it, which leads to an uncomfortable finding in that same work. A stronger retriever can sometimes make things worse because it's better at surfacing convincing near misses. So the real enemy is not general noise. It's the near miss. Prioritize precision over raw volume. 3 quick ones. Waste 11, 12, and 13. First, arithmetic waste. Give me 20 ideas before you've defined what you're solving for. You'll use 2. You paid for 20 at output rates. Define your audience, your goal, and your constraints first, then ask for 5 strong options. Second, full regeneration. You want 1 paragraph change, so you ask for the whole document back. You pay full output price for the 95% that didn't change, and every regeneration is a fresh opportunity to break something that was already correct. Ask for a diff or an explicit list of edits. Third, reasoning overkill. This one is expensive and invisible. Thinking tokens are a subset of your max tokens. They're billed as output tokens, and they count toward your rate limits. So leaving extended reasoning on for extraction, formatting, or simple rewriting means you're paying output tier prices for deliberation the task never needed. Reasoning on for planning math and hard debugging, off for mechanical work. Last one, and this is the one that keeps all the others alive. Most teams track total token spend. That number tells you almost nothing because it has no denominator. Here's the formula that matters. Total token spend divided by successful business outcomes. Resolved tickets, merged pull requests, reviewed documents, completed jobs. That gives you your true token costs. Without that denominator, a rising bill just looks like growth. You cannot tell the difference between an expensive system that works and an expensive system that's wasting most of what it spends. So to close part one, here's the rule of thumb. Smallest context, cheapest capable model, clearest prompt, shortest useful output, and caching or retrieval whenever context repeats. Now, you might be thinking, fine, it costs more, so what? Because the money is honestly the least interesting part of the bill. Token waste also makes your answers worse, your app slower, and your bugs much harder to find. Thanks for watching.